SwayamPrabha. Digital India. Educated India.
Hello everyone. Now we will continue with the module 1, like introduction to textiles for human protection and functionality. So, first we try to understand why the protective textiles matter. So, we must understand the reason to use protective textiles. Unnecessarily we should not use anything which is not required. Okay. Protective textiles serve as a critical barrier between human and hazardous environment. If you see, this is our body and here the hazardous environment is there. So, we need a barrier between the hazardous environment and the our body, human body. This hazardous environment may be anything, as we have discussed in last session, like it may be heat, may be cold, may be gases, may be fire, okay, may be mechanical threats. So, to protect ourselves, we need one protective layer, and that can be actually provided by the textile material, proper textile material, which we call it as protective textile. Okay. From scorching flame to deadly chemicals. So, we need protection. Okay. These specialized materials defend against natural, industrial threats, including extreme heat, fire, toxic substances, UV radiation, biological contaminations, anything, sound. So, we need textiles, and which will protect us from all these environments. And you see, for extreme situation, this type of clothings are actually indispensable. In firefighting, a firefighter cannot enter into a building with a fire, structural fire, without proper firefighting gears. In military operation, one army personnel cannot go in front without bulletproof jacket. In everywhere, in be it healthcare facilities, chemical plant, extreme outdoor environments like extreme cold, heat. So, we need this type of protective textiles. The ultimate challenges in protective textiles, which to achieve the perfect equilibrium, the maximum protection without sacrificing the comfort, mobility and breathability. That is the perfect requirement. So, we cannot sacrifice the comfort, because if the protective textile is not comfortable, then people will not be able to perform on its optimum level. So, they can perform effectively while staying safe. So, to stay safe we need protection, and to perform effectively we need comfort, mobility and breathability. So, that is very important aspect. So, then what are the functional textiles? Basically it integrates performance, the textile engaged with built in functions far beyond the traditional aesthetics. So, normally clothing is used for traditional aesthetics, but here it is far beyond the traditional aesthetics, combining from with the intelligent functionality. So, we sometimes use the intelligent functionality. So, that we will be discussing in detail. The smart capabilities are required in the functional textiles, like temperature regulation, moisture management. So, these are the functional regulation, functional requirement, UV resistance, antimicrobial, antibacterial properties, adaptive response to environmental conditions, like in phase change material we use. If there is a heat, then it will actually not allow the heat to come within the to the human body. So, it will protect us. To enhance, it will actually help in enhanced living, like transforming comfort, safety and performance. So, you have to actually provide the comfort, safety and also the enhance the performance in everyday life. So, these are the requirement of functional textiles. So, key types of protective textiles are there, like thermal and flame resistant textile. So, what we have used the protective textile I have mentioned the broad wide range of protective textiles, but if we try to see the what are the key where the incidence or major incidence takes place, one is the thermal and flame hazard. Okay. So, here to develop protective textile we need high performance fiber. Nowadays it is high performance fibers are being used, like advanced materials like Nomex, Kevlar. So, these are the patented technologies by DuPont. So, that there are now these are actually aramid fiber. So, there are many other companies they produce the aramid fiber, they are it is commercially available, that withstand extreme temperatures and resist combustion. Okay. These are essentials for firefighters and industrial workers from the heat hazard. So, we need different types of fire protective fibers. Next is the chemical and biological protection. So, specialized fabrics are being used for chemical and biological protection. Mechanical defense, that we have already mentioned, that cut resistant, abrasion proof, ballistic resistant textiles are used. Okay. And fourth one is that radiation and electrical shielding. There are radiation protective like UV radiation and maybe electromagnetic shielding, different types of radiation we from the we can protect ourselves from the different types of radiations. So, these are the broad areas, but apart from this there are many other areas like noise pollution, noise protection, air pollution. So, this type of protective textiles are used. Now, what are the different fibers? Different fibers are majorly used. One is that aramid fiber. So, aramid fibers, the meta and para aramid fibers that are being used, okay, and which deliver exceptional fire protective characteristics and ballistic protection, used for body armor, firefighter gear and airspace. So, there are different types of fibers are being used. Carbon fibers, so aramid fiber, then carbon and glass fibers. These are they offer very actually that structural reinforcement. Carbon and glass fibers are used there for structural reinforcement, but for their strength, modulus, and critical for high temperature environment and composite materials. So, there we use for all these applications and specialty synthetic fibers like PBI, PTFE, okay, and fluorine containing fibers provide unmatched chemical resistance. So, there are different types of chemical resistant fibers which protect ourselves from corrosive substance and extreme conditions. So, these are the specialty fibers are being used, and emerging some sustainable fibers are used. Next generation eco-friendly fibers combining environmental responsibility with high performance protection. These are the different types of fibers broadly in these areas. Okay. Now, apart from the fibers and fabrics, there are different functional finishes and treatments are being used. You can see antibacterial and anti-mite finish fabrics are used to protect ourselves from different types of bacterial elements or harmful bacteria or dust mites, okay, and UV blocking coating. So, apart from the fiber, different specialist fiber and fabrics used. So, there are specialized UV blocking coatings are used like for like SPF, sun protective creams are there. So, which these are the type of, and there are for textile materials there are different types of UV blocking coatings are used. So, specialized treatment that absorb or reflect ultraviolet radiation. So, which prevents our skin from damage from the UV radiation, and moisture management treatments are there which increase the moisture wicking technology and breathable membrane. So, this breathable membranes are being used on the fabric surface by coating, which actually prevents any hot water splash or hot metal or material, or maybe some objects from metal liquid objects from outside, but it at the same time the micropores allow the moisture from the human body to come out, and which maximize the comfort. And flame resistant treatment, there are apart from the flame resistant fabric fibers, there are chemical treatment we use that for like normal fabric like cotton, which is actually flammable, but if we treat with the chemical flame resistant finish. So, that will be the LOI value will increase. The chemical treatment or self extinguishing fabric technology that prevent ignition. Okay. What are the future of smart protective textiles? Okay. You can see. So, there are different areas where research is going on, and in the future protective textiles we can use nanotechnology integration. So, that nanoparticles enhance the protection and functionality. So, that nanoparticle can be incorporated like your antibacterial like silver nanoparticle is integrated within the fiber structure. So, that will be actually inherently the fiber like antibacterial polyester. That means, if you incorporate some particle nanoparticle silver nanoparticle, that fabric itself will be or fiber itself will be antibacterial. So, there are different types of nanotechnology integration is possible like adaptive materials. Okay. So, nano silver or antibacterial action liquid body armor, okay, like your some STF, okay, shear thickening fluid, if we can actually incorporate within the fabric structure, and that will be at a higher impact, this will be become it will be actually hardened, it will harden and it will prevent our body from any injury. And phase change materials which actually regulates the heat. So, this is also important. Responsive fabrics, textiles adapting to environment, okay, and cool color changes are there. So, there are adaptive fabrics are there, their color changing sensors are there, heat emitting fibers are there, okay. There are fibers which emits heat at when it goes to different environment, it emits heat, and energy harvesting capabilities, or for movement, during movement energy harvesting is the energy, it can store energy, or at the sunlight it can store the energy. And the basic challenge in all these innovations are the balancing the cutting edge smart feature with practical wearability. So, we have to actually practical wearability. So, all these things we have to see that whether we have to see whether this is actually not is it affecting the comfort characteristics, that we have to see, and its a durability, we have to check the durability, and cost effectiveness. Our protective textile is okay, and but if we try to incorporate all these intelligent smart features, it should not be very expensive. So, that we have to see. Now, let us see the real world applications. So, firefighter protection, okay, in advanced suit. So, in smart textile, if we try to use the smart features in firefighter clothing. So, advanced suit combination, heat resistance, flame protection and moisture barrier. So, we can create fabric different layers which will be heat resistant, which will be flame proof, and at the same time moisture, it will allow the moisture from our body to come out, and at the same time from any other, from water splash or hot water or something, it will prevent, okay, enabling the fast response to enter inferno and save lives. So, for this, that will enable for any firefighter to enter into a inferno. Okay. So, military defense, the thing is that in real life scenario, in military defense, the lightweight ballistic protective for soldiers, and which will protect from projectile, shrapnel and blast, okay. That is important, and healthcare and safety. So, for healthcare personnel, we must use the antibacterial surgical gowns, okay, and different isolation garments preventing infection from transmission, okay, from one patient to another patient. That will be that is very important. And outdoor performance. So, there are different types of outdoor performance are there in outdoor. The technical actually outdoor gear provides UV protection, weather resistance and moisture management. So, for athletics and adventure in extreme condition. So, that these are the different types of real life scenario, and there are different environmental and ecological considerations are there. You can see the industry impact. Okay. The textile sector significantly actually that which actually significantly leaves the ecological impact from consumption of water, chemical use and waste generation. So, that actually it creates the enormous impact, carbon footprint it gives to the environment world, and for that we need a green innovation. So, there are we need for protective textile also we need green innovation like in for aramid and all. So, this after usage this should not go into waste. So, we can actually reuse this try to recycle all this protective textiles, that is basically challenge nowadays. So, green innovations are important, develop either we should develop the biodegradable material, okay, but most of in many cases it is not possible. So, if it is not possible biodegradable material, then what we have to do, we have to create a material, we have to system to recycle all this material. So, the dual protection, next generation protection textile, actually that protective textile designed to safeguard both human and planetary health. So, our world and we have to protect. So, creating sustainable future for functional material. So, we have to create some sustainable material like recycling is one of the ways, or biodegradable material is required. The future of protective textile lies on not just the protecting people, but the protecting the planet that sustains us all. So, that is that should be our motto. We should not develop a material which only protect ourselves. So, we should actually try to protect the planet. Okay. Now, what are the sustainable developments? Essential, this is essential for life. Okay. The protective and functional textile are fundamental to safety of health, comfort across the countless industries application. The innovation driven progress, continuous material development has to be there. Okay. And the road ahead is that tomorrow's textile will be a smarter, more sustainable and dramatically more effective. Okay. Integrating AI, self healing properties and environmental sensing. So, these are the different approaches one should go ahead with the protective textiles. Through relentless innovation. So, many innovations and the commitment to sustainability, protective and functional textiles will continue to safeguard lives, enhancing the human performance and improving the quality of life for generations to come. So, that should be our motto. And now, we are going to discuss the fiber science for protection. Different types of fibers are being used, and that the exploring high performance fibers in modern protective textiles. So, here we will try to see the high performance fibers for protective applications, but in our module 2 we will discuss the all the fibers in details, their characteristics and all that, but here we will try to understand what are the different fibers are being used here. So, the classification of fibers you can see here. Natural fibers are also used in protective textiles. Cotton, flax, hemp offers comfort and breathability. So, in one of the layers in multi-layer fabric we use this natural fiber to enhance the comfort characteristics. Like cellulose based fibers are there, and protein based fibers are also used, like wool, silk provide natural thermal regulation. So, for thermal like extreme cold protective, so we sometimes use the wool. So, this type of natural fibers are down feather is also used. So, for protection natural fibers are used, regenerated fibers like semi synthetic, like regenerated cellulosic fiber, rayon, lyocell combined natural polymer with engineered processing. Okay. So, this bridge between natural comfort and enhanced performance. So, this natural synthetic fibers are stronger than normal natural fibers, but at the same time they create the comfort also. And synthetic fibers are fully engineered fibers like nylon, polyester, aramid fibers. So, they are widely used for protective textiles. So, key distinctions include fiber origin, molecular polymer structure, manufacturing process and resulting performance characteristics that determine the protective capability. So, that means that you have to select fiber based on the requirement. Okay. Now, high performance fiber, if you see the engineered material used for ultimate protection. So, we have seen the commodity fibers typically and high performance fiber, engineered fibers for ultimate protection. You can see high performance fibers are basically this advanced material exhibit tensile strength, high tensile strength, high temperature resistant, okay, high flame resistant. So, there are impact resistant and they are high resistant to chemical exposure or gaseous exposure. So, this type of extreme condition. So, high performance fibers are used like airspace applications. So, aircraft structures, thermal barriers like carbon fibers are used. Okay. So, there are different types of high performance fibers are used, ballistic protection. So, body armor, helmet, vehicles. So, this type of high performance fibers are used for this industrial safety, cut resistant gloves, protective clothing. So, for all these applications we use high performance fibers like aramid. So, if you see aramid, it is a Kevlar Nomex is basically a trade name of DuPont, but apart from this, as I have mentioned, many aramid fibers, many companies are there, the commercially available aramid fibers. So, these are the protective textiles. So, Kevlar ballistic protection, for ballistic protection we use Kevlar fiber due to its high strength, okay, 5 times stronger than the steel by weight, yet it is a flexible and lightweight. Okay. That is a beauty of this fiber. Its application is in bulletproof based ballistic helmets, cut resistant gloves, reinforced cables. So, there many applications are there due to its lightweight there and its flexibility. So, it actually creates comfort also, you can create comfort and high strength, it is very high strength, low elongation and it has got excellent impact strength. Now, next is the Nomex, which is also aramid fiber, it is meta aramid fiber, it is a thermal guardian, it calls thermal guardian. Basically, it is a high temperature resistant, heat resistant, withstand the continuous exposure of high temperature like up to 370 degree Celsius without any degradation, that is important. Many fibers are there with high melting point, but it degrades fast. So, this is very important. The applications are for firefighter gear, okay. So, airspace applications. So, this type of fibers are used and highly flame resistant, thermal stability okay, dimensional stability is there, integrity is there. Ultra high molecular weight polyethylene fiber, this is also this represent the quantum leap in fiber technology, achieving the extraordinary tensile strength. Okay. It has very good tensile strength due to its extremely long polymer chain. Okay. And it is if you see the 15 times stronger than steel by weight comparison. So, for same weight it will be, it is a 15 times stronger. We can imagine where we need lightweight strong material, flexible material, we should go for the ultra high molecular weight polyethylene, and its specific gravity is less than water, that means it floats on water 0.97, and its melting point it is not too high. So, that is why ultra high molecular weight polyethylene is not used for high temperature application, but where the strength is important, there we use this UHMWP. Okay. So, commercially available fibers, Dyneema is one fiber, it is a soft body armor or ballistic protection due to its high strength. Okay. Cut resistant gloves we can use, marine rope and lifting strings. So, due to its strength and the low specific gravity, it floats on water, it is a lighter, stronger, that is why in marine rope we use. Okay. And medical implants and suture, because it is a it does not react easily. So, that is why we can use it as a suture, it does not degrade easily. So, spectra, okay, this is again one ultra high molecular weight polyethylene, and this is lightweight tactile equipment, sailing lines are different, climbing gears, different types of applications are there. Next high performance fiber is the carbon and glass fiber. If you see the carbon fiber, which is actually exceptional stiffness, okay, that means very high modulus. So, where the high modulus is required with a low high modulus of elasticity, and that type of application we use carbon fiber, okay, like aerospace, okay, Formula 1 chassis, okay, wind turbine, where we do not need any extensibility. So, high modulus. So, for that application we can use lightweight, okay, ballistic helmets, and it maintains strength. Okay, it is a very high temperature resistant, and around 2000 degrees Celsius it maintains its strength. So, where high temperature strength is required like aerospace structure. So, for this type of application we use carbon fiber, okay. And glass fiber, its excellent strength to cost ratio. So, it is it is not that strong like your carbon fiber. The main disadvantage of carbon fiber is it's expensive, and if you need low cost high strength fiber, so glass fiber is one alternative. So, a little bit cheaper product like boat hulls, building insulation, okay, circuit board, protective reinforcement. So, there we can use, okay, and it is a corrosion resistant. So, where the chemical hazard is there or some corrosion. So, for that like boat, where it goes, it is basically under saline water, it is always there with the that. So, for those application we can use glass fiber. And composite, different types of carbon and glass composite, we can composite combination we can use depending on the application. So, this glass and carbon fibers are basically used in many composite applications. And basalt and different next generation ceramic fibers are there for their thermal protection. So, basalt fiber, if you can say natural origin, okay, produced from the molted volcanic rock, okay, and it has thermal stability, it is stable at temperature around 700 degrees Celsius, it is chemical superior chemical resistance, and it is eco friendly because it is sourced from environmental source, and ceramic fibers are extremely high temperature resistant, withstand up to 1800 degrees Celsius, low thermal conductivity. So, for that exceptional insulation performance we can use, a lightweight protection, high temperature barrier where we require, and critical application aerospace applications at different thermal shield we can use, and industrial furnace we can use the ceramic fiber. And the emerging trend is that basalt and ceramic fibers are gaining popularity in sustainable composites, because these are sourced from the nature. So, for different types of sustainable composite where we need to reduce the carbon footprint, we can use the basalt and ceramic fibers. Now, the future of fiber science in protection. So, continuous material innovations are important, where basically we have to see the we have to see the different material development using nanotechnology, and it should be requirement should be lighter, stronger, high temperature resistant, and at the same time it should be basically environmental friendly, sustainable fibers we should go for. And then smart integration should be there, we can incorporate nanotechnology, we can actually smart fibers, traditional high we should actually go towards the smart fiber, okay, which creates adaptive protection, okay, and sustainable solution. So, biodegradable bio based polymer we should use, and multi-thread protection. So, one particular fiber we should go for the which will be actually used for ballistic as well as the bacterial or heat or chemical. So, multi-thread protection fiber we should try to create, okay, because we do not know the what type of thread may come. So, one we should go for the idea, can we create a particular protective textile which will be which will protect ourselves for any type of threads, okay. And fiber science remain the pivotal in safeguarding people and infrastructure, because so yarn development and the fabric development or cloth development is one issue, but mainly fiber development is key to develop protective textiles. Okay. As threats evolve and operational demand intensify, the fiber science community continues to innovate, ensuring that the protective materials advance faster than the challenges they are encountering. So, they must overcome these challenges. Now, after fiber, now let us see the what are the different fabric structures for protection. So, we must understand the foundation of high performance textiles. So, oven structure, if you see for protective textile, we if we use the oven structure, there are typically three few open structures are used: plain, twill, satin, sometimes ripstop So, this type of different structures are used. We will discuss in detail in next module. Basically fundamental design, if we see, these are the weaves like plain, twill and satin. These are the fundamental weave and each offering unique properties. So, let us try to understand the three design, but apart from this three design, in woven fabric, as I have mentioned, there are different honeycomb weave is also used, like ripstop is very popular in protective textiles. Now, if we see the plain weave is basically simple over under, like over and under type of pattern, creating maximum thread intersection. In this weave we can create maximum thread intersections. Okay. So, the interlacement points. So, the structural integrity is very strong, okay. Highly durable due to the high number of interlacements, and it is dimensionally stable, making it ideal for heavy duty protective textiles. So, due to its dimensional stability, so for heavy duty industrial workwear or protective application, we can use this plain weave. Now, twill weave is a distinctive diagonal rib patterns. Okay. So, this due to this rib pattern formed by offset interlacement. Here just one over under, but here if you see it is a offset, like 2 up 1 down, or this type of structures offset interlacement is there. So, but this structure is not that stable or dimensional stable like your plain weave, due to its less number of intersection. So, offering superior drape, enhance abrasion resistance be due to the thread actually movement. So, it increases the abrasion resistance like your biker's denim. Okay. So, this type of where the chances of abrasion is there. So, this type of application we can use the twill weave, okay. Commonly used for protective workwear and technical outerwear. So, due to the higher resistance compared to the plain weave, so we can use this type of twill structure. And satin, long floats yarns create a smooth lustrous surface, okay, while less abrasion resistance due to the high float. So, abrasion resistance will be less because one side like warp or weft side is actually prominent in one surface, one side. So, that is why it actually abrasion resistance is less, whether comfort and appearance matters alongside the. Now, woven fabrics for cut and puncture resistance. So, if you see high performance woven fabrics integrate advanced material to dense engineering structure that resist material mechanical threats. So, we can create woven fabric to prevent us from cut and puncture. So, key performance parameters are high performance fibers like ultra high molecular weight polyethylene or Kevlar woven into dense and protective structure. So, we can, if we can create a fabric dense fabric with this type of fibers. So, we can create a cut puncture resistant fabric. Tight weave, we should create the tight weave to actually prevent from knife edge or sharp objects. So, so that they should not penetrate, and suitable for medium and high hazard environment. Okay. So, this woven fabrics we can use for that, and knitted structures are sometimes used for protective textiles. Knitted fabrics are of two types, weft knitted and warp knitted. If you see these knitted fabrics offer unique advantage in protective application by combining the flexibility, breathability and comfortability. So, if we can create a knitted fabric comfort characteristics, so there you will see it will create the protective textile with a high comfort. So, these are the flat knit ultra high molecular weight polyethylene fabric achieve cut resistant classes of A4 to A5. So, it is a very good we can see. So, weft knitted fabric loops form horizontal across the width of the fabric, highly stretchable, these are the characteristics, flexible, prevent superior that provides superior comfort and mobility, and ideal for application require body comfortability and freedom from movement, okay, freedom of movement. And warp knitted fabric, the loops are from along the fabric width vertically, this is vertically along the fabric length. So, it is earlier it was weft knitted along the width, here vertically across the width, and here vertically along the fabric length. Okay. These are the more stable with controlled stretch characteristics. So, it is not stretchable like weft knitted fabric. So, these are used for technical protective gear in requiring dimensional stability, where dimensional stability is required. For those applications we use warp knitted fabrics. So, needs for comfort and mobility of protective textiles, where we need mobility, protective textile where we need mobility. So, advanced technology 3D knitting, rib knittings are used, ergonomic protection. So, it is ergonomically it should be comfortable like knitted protective gloves. So, where gloves we need our finger has to be moved frequently, we have to grip somewhere, we have to. So, for those applications we need knitted protective textiles. Here if we try to use the oven or say non-oven, there our movement of fingers will be restricted. So, okay. So, natural hand movement will be restricted. So, high performance integration. So, if we use the high strength fiber, high performance fiber in the knitted structure, that will provide the protective textile like protective gloves. Okay. So, non-woven structures are also used for protective textiles widely, different types like your antibacterial protection, PPE medical application where non-woven structures are used. So, these are basically spun bond, melt blown, needle punch, even nano wave also we can use, okay, represent a versatile class of engineered textile create without traditional weaving. So, here we do not need any yarn production or maybe weaving or knitting, directly from the fiber we can create fiber or filament. So, spun bond technology, continuous filaments are extruded, bonded for exceptional strength and durability in protective barriers. Melt blown process is there, ultra fine fibers are created and dense web which creates dense web with superior filtration efficiency and barrier properties, like for protecting ourselves from the pollution, air and water pollution, we can use melt blown non-woven fabric, and needle punch is very widely used for protective textiles like your extreme heat protective or cold protective textiles we can use, or many other applications and these fabrics are widely used for disposable PPE, medical protective equipment, filtration system, composite reinforcement, okay, due to their cost effective. So, they are relatively cheaper. Now, 3D fabrics like we use for knitted for protective textiles, these are the spacer fabric or multi-layered structures. If you see the spacer fabrics application, the two distinct layers are there. You can see the two distinct layer. Here is a one spacer line, this is another spacer line, okay, and they are connected with the threads, okay, and due to their this structure they create comfort, okay, in the protective textiles. And multi-layered 3D fabrics, you can see that the 3D layers are there. These are extremely high protective, advanced 3D combined different fiber orientation and material type in single structure. So, you can have different types of combinations. It gives a material mechanical performance, thermal insulation, okay. These applications of this spacer and multi-layered fabrics are the protective clothing with impact resistant, automotive application, automotive interior we can use, composite materials we can use. So, composite fabric laminates and laminates are very important. So, normally if you see the single layer textile materials are not in use for extreme condition. So, there we need multi-layered structure like composite integration is that oven with actually with a knitted or non-oven we can use, they are bonded sometime, and to each layer will perform its own distinct function. So, for that we need multi functional protective textile and functional laminates are additional addition of a specialized layer including waterproof membrane, waterproof breathable film is laminated with the non-woven fabrics to create fire protective suit with breathable. Hybrid composites are used for like your integration of metal fiber or carbon material or ceramic panel with the within the textile to enhance the protective performance. So, let us try to see the how to choose the right fabric structure. So, each fabric has their distinct advantages in protective performance, and selection depends on the specific hazard. What type of hazard is there that we should comfort requirement and performance properties. If the hazard requirement level is low, so we should select different types of fabric depending on the hazard type. So, woven fabrics are used for maximum strength and cut resistance. So, that if where we need high strength and cut resistance, and the trade off is the limited flexibility and drape. So, woven fabric has got limited flexibility because of the warp or weft side, it is not that flexible. For heavy duty industrial protection cut resistant we can gloves we can use for only for heavy duty industrial protection. Now, knitted fabrics where comfort and body the movement is mobility is required. So, there we should go for comfort knitted fabric. The main trade off is that its protection level is not as high as the woven fabric. So, application flexible PPE ergonomic protection protective garments and non-woven is basically for filtration, barrier, disposable protection like your PP medical application. So, there we can use a barrier fabric for filtration like for gas or air, water pollution, we can use this non-woven fabrics, medical PP. Okay. So, that is the filtration system we can use, and 3D composites are multifunctional advanced protections where we need multifunctional material. So, there we can go for the 3D composite material, high complexity and cost is very high. Okay. So, aerospace application, defense, specialized industrial application. So, 3D and composite we can use only where very specialized application. So, there where the price is does not matter. So, that is why we have to use the particular application. Now, future of protective fabrics. Innovation and integration of next generation safety. So, hybrid material system. So, we can go for the hybrid material which will be used for multi-thread. Advanced manufacturing we should use 3D knitted structure, knitting technology, electro spinning we can use, nanofiber layer we can use for breathable ultra durable PPE kit, and sustainable development. So, all the developments which we do, it should be sustainable. So, we should go for bio based fiber, recycled high performance material or circular economy, we should go for this, and closed loop recycling system makes the protective textile more sustainable without compromising the safety. So, these are the future of protective textiles. The vision for the future is the future lies in protective textiles that seamlessly blend safety, comfort and sustainability, creating next generation solutions that workers actually want to wear while meeting the highest protection standards. So, this is the basically this should be the vision for the future. So, we will stop at this point. Next session we will discuss the comfort and functional properties of textiles for human protection. Thank you.